Hello, I'm Phil Cayton. I'm a principal engineer at Intel. I help coordinate the activities of the main NVMe technical working group, and I'm one of the co-chairs of the NVMe boot task group. I'm going to give an update on the state of NVMe, discuss the NVMe activities since the last major release of specifications in 2021, announce some new specification versions from NVMe as well as a couple of new specifications. Then I'll highlight just a few of the features and capabilities that you'll find in the new NVMe specifications. Unfortunately, I don't have time to go into them in great detail, but we have some great talks both here at this forum in this session and later on today. Also, there's some great webinars and blogs on the NVM Express website that I recommend you go to. But then I'll conclude with the future, the plans and roadmap for the NVM Express activities through 2025. But before we discuss what's technically new and the plans for NVMe, let's take a look at the NVMe landscape. This slide is, and the data is courtesy of our friends at IDC, and it shows enterprise SSD capacity shipments broken out by interface. You see at the bottom, you see SAS. Above that, in that kind of orangey yellow, you see SATA. And above that, in the darker blue, you see PCIe-based, NVMe-based SSDs. Most PCIe-based SSDs are NVMe. And above that, in a very slight sliver of green there, you see other interfaces. And that includes things like Ethernet. You can see there in the left, at the beginning of the study in 2020, NVMe dominates the interfaces for enterprise SSDs. And by the end in 2027, NVMe pretty much is the enterprise interface of choice. All other interfaces become essentially niche. NVMe has become the language of storage. I do want to point out there in 2023 and 2024 where shipments of enterprise SSD capacities either are projected to lag or have been seen to lag those of 2022 before recovering in 2025. A couple of reasons have been brought forward. Concern about the macroeconomy, which has created some cautious spending amongst IT users, longer than expected inventory adjustments following strong shipments following the pandemic, and retooling and optimization strategies which have delayed purchases. Shifting from enterprise to consumer SSDs, this is broken out, this is PCIe SSD shipments, and this is by capacity on the left and units on the right. I don't see much of any perceptible dip in shipments. Looks like everything might slow down a little bit, but it's looking great into the future. And this is PCIe consumer SSDs. Remember, NVMe supports more than just PCIe. NVMe supports Fabric. It supports NVMe over TCP, NVMe over RDMA fabrics, and NVMe over Fiber Channel, with the possibility of adding other fabrics in the future should the industry require. Shifting from the market to NVMe activities, since we released NVMe 2.0 base specification and the other associated specifications in about June of 2021, we've started roughly 71 new technical proposals. We've ratified roughly 82 technical proposals, and we've ratified 22 or so ECNs. I want to pause there and kind of unpack that a little bit. When a company or a group of companies wants to add a new feature, a new capability, a new enhancement, something new, technically new into the NVMe specifications, it all starts with a TPAR, a technical proposal authorization request. They'll come to the technical working group, they'll present their idea, lay out what their vision for the scope is, any perceived NVMe ecosystem impact, and if the NVMe technical working group and the NVMe board of directors agrees this is an idea worth pursuing, it'll become a TP, a technical proposal. And then the technical proposals work through the technical working group and the associated task groups to hone the idea, to lay it out with what it'll look like in the NVMe specifications, how it'll impact anything else in the specifications, and make sure that it's something that we want to be standardized in NVMe. And if the NVMe technical working group and the board agree that then they'll ratify it, and it will become a ratified technical specification that's available on the NVM Express website once it's ratified. You don't have to wait for the new specifications to be released. They merely aggregate all the work that's been done since the previous specification releases. ECNs, engineering change notifications. As we're working through the specifications and adding new things. We might find areas that need to be corrected, non-technically, areas that need to be clarified, areas to make interpretation easier. And so we address those through ECNs. So, but let's talk about specifications. Let's shift gears a little bit. When NVMe base specification 2.0 was released, there were 8 specifications. Since then, we've added a couple of command set specifications and the boot specification, which I'll talk about in a bit. But we now have the NVMe base specification released at 2.1. We now have 5 command set specifications. We have the NVMe NVM command set, which is what people think about when they think about NVMe. It describes traditional block storage. We have the NVMe zone namespace ZNS command set specification at 1.2. We have the NVMe KV key value command set that's being released at 1.1. And we have the 2 new command set specifications, the subsystem local memory command set and the computational programs command set specification, which you'll hear more about in the next presentations. We also have the transport specifications, NVMe over PCIe, NVMe over RDMA, and the NVMe over TCP transport specification. Those are released at 1.1. We also have the NVMe management interface specification, which is being released at 2.0, and the NVMe boot specification. That was released at 1.0 after the last major release specifications, and so we're considering it a new specification, but it's also been revised to be up at version 1.1. And if you compare the total page count from the release of the NVMe 2.0 specifications back in 2021 to the page count of all these specifications, it's increased by roughly 48%. So it represents a lot of new features and enhancements and capabilities that you'll find in the new specifications. And I'm not going to have time to talk about even most of them, but I will highlight some of the more marquee items, some of the ones that we really wanted to call out. And we've somewhat arbitrarily divided them up into 5 buckets here. There's fabric enhancements, there's emerging technologies, there's security enhancements, there's data and virtual machine migration, and then there's management. And starting there under fabric enhancements, there's the NVMe boot work through the aforementioned NVMe boot specification and the parenthetical statement there. That's the major technical proposals that went into building it. Then we have discovery controller enhancements and fabric zoning, which I'll go into in a little bit more detail in a couple of slides. We have emerging technologies with the computational storage through the computational programs command set, flexible data placement, and the NVM subsystem memory through the subsystem local memory command set. Again, you'll hear more about that. Been doing a lot of work on security. For security enhancements, we have key per IO, we have post sanitized media verification, and fabric security enhancements, a basket of them. In fact, I'll go into them, but this does include support for TLS 1.3. Under data and virtual machine migration, we have PCI infrastructure for live migration. There's a really good talk with great animation, and there's actually a demo on live migration, so I'm not going to talk much about that. There's cross namespace copying, and there's the tracking of LBA allocation with granularity. And then I personally spent a lot of time on management. Scalable resource management was one of the TPs I championed. There's high availability out-of-band management for asynchronous events, and management support for I3C, which I think people will find very interesting. And I wanted to note there's going to be a companion document on the NVM Express website that I just finished getting together along with all my colleagues. And it's about 69 pages and goes through each specification and kind of summarizes the technical proposals and ECNs that affected each, and so what you'll find in the new versions. So, don't have a lot of time left, so I'm going to go into just a few of the new features, and I'm going to start with the boot specification and the boot work. The boot specification, it defines general concepts for booting over NVMe. It contains an overview for boot stages and flow in a UEFI pre-operating system environment, as well as laying out some best practices for reliable operating system consumption of pre-boot configuration information. It includes mechanics such as ACPI tables to enable pre-operating system and operating system environments to share configuration context. And I wanted to clarify, the boot specification is eventually going to be the specification for all things booting over NVMe. But since booting over NVMe over PCIe is already well understood and in wide use, we concentrated for the first couple of revisions on booting over NVMe over fabrics, and particularly concentrated on booting over NVMe over TCP, since TCP/IP is fundamental to many data centers. And we have an open source reference implementation for booting over NVMe over TCP that's working in Linux. Recent enhancements that have gone into the 1.1 version of the boot specification include standardizing the format of UUIDs displayed in an NVMe boot firmware table, adding support for IPv4 and IPv6 DHCP identifiers, and improving error codes for common subsystem connection failures. This is one that is kind of important if a system's been provisioned for operating system namespaces or data namespaces or scratch namespaces. Once it comes up and cannot connect or reconnect to them, you're going to want your administrator and your test engineers to be able to get the breadcrumbs to figure out why. Moving on to discovery enhancements, we have NVM Mirror Fabrics automated discovery. So unless you want your NVM Mirror Fabrics host to have to be administratively configured or statically configured through scripts to know what discovery controllers they should go to find out what resources they're allowed to access and how to access them, you want automated discovery, which lets the hosts understand this is the discovery controls I need to go to, and they can go and ask them. We also have a centralized discovery controller, kind of a one-stop shop, if you will. This consolidates and aggregates all the individual direct controller, discovery controller information. It enables discovery information to be consolidated and retrieved from a centralized single source. And so a host can just go to the centralized controller and ask for the resources and be told what resources it's allowed to access. And the central discovery controller works by push or pull registrations and updates from the other discovery controllers. And so it can provide that bespoke list, if you will, to the hosts. And the centralized discovery controller uses fabric zoning for enforcing access controls through a couple of databases there, and there are some good talks on it. Fabric zoning, essentially, it's a modern take on discovery subsystem access, similar to how fiber channel zoning previously improved access and security within the fiber channel fabric. Moving on to key per I/O. This is a new feature that was developed in cooperation in concert with the Trusted Computing Group, TCG, to enable storage device support of host-managed storage. The high-level goal is to provide a more dynamic and finer-grained encryption of data. So instead of a single encryption key for the whole device and the users of that device, key per I/O enables host-managed data encryption keys to be used by the NVMe storage on an I/O command basis, and expand granular capabilities for host data encryption. And so it's a very good security enhancement. Continuing on with security, as I said, there was a basket of security enhancements. This is just a few, and there's actually a link at the bottom to a presentation which goes into much greater detail. But we did include NVMe over TCP TLS updates, redesigning how TLS is used to improve security, to remove some of the key identification ambiguities, and add text which strongly discourages the use of TLS 1.2 in favor of TLS 1.3 for improved security. We also added a centralized authentication and verification entity, an AVE, for Diffie-Hellman HMAC CHAP. And this removes the need for widespread deployment of pre-shared keys for authentication and verification. The keys are really deployed on the entities, the hosts or the subsystems that need to do the authentication, and the centralized AVE authentication verification engine that performs and verifies the people. We also added NVM Mirror Fabric security configurations for consistent behavior based on the individual configuration of the entities, the hosts or the target subsystems. And so there is a presentation, as I said there. Moving on to PCI infrastructure for live migration. There is a really good talk later on. I've seen the slides. There's some great animations. I highly recommend you attend it. Live migration, it provides building blocks and addresses management and security concerns by supporting the migration of virtual machines from one NVM subsystem to another. It enhances data center maintenance and processes such as load balancing. You might want to take a heavily loaded machine and move one or more of the virtual machines to other subsystems on other devices. Or for system maintenance, you might want to shut down a system for maintenance, reprovisioning, moving the system. And so you'd want to move all the virtual machines off of that, migrate them to other subsystems on other devices. And it really works by putting the virtual machine and the associated NVMe controllers and namespaces into a static state and migrating that state to another subsystem and then resuming the virtual machine without the virtual machine even being aware that it was migrated. Again, I'm just glossing over this at a high level detail. There's a lot of nuance, but live migration is broken down into really 3 sets of host actions. You have the pre-copy phase, the stop and copy phase, and the post-copy phase. So attend Mike's talk. It's going to be a good one. Scalable resource management. I champion this one. I spent a lot of time on it. This is a standardized way of configuring NVMe resources over fabrics in dynamic environments to avoid the unnecessarily static configurations, avoid the vendor-specific configurations and proprietary necessary of configuring NVMe or fabrics resources in dynamic and heterogeneous infrastructures. It certainly saves management and administrative overhead. At a high level, it defines standardized framework to dynamically construct, configure, and provision NVMe resources over fabrics using underlying physical, if you will, NVMe resources. I'll unpack that just a little bit. If you have a storage target, you probably have more of them. But if you have a storage target with NVMe namespaces on NVMe drives, and you want to expose those over fabrics, and that storage target has got fabric devices that are supported by NVMe. Right now, you really pretty much go to each storage target. You figure out what NVMe drives and namespaces you have that you want to export. You figure out what fabric devices are on there that are supported by NVMe. You construct an NVMe or fabric subsystem. You populate that NVMe or fabric subsystem with associations to those physical underlying resources. You tell that subsystem how to expose itself over fabrics using a transports, one or more. And then you might have to deal with access control if you want to restrict access to the subsystem and namespaces to specific hosts. And so, and if you have to do that every time the system boots, or you have a static configuration, it's not really going to work in a dynamic infrastructure with changing workloads, changing data sets, changing provisioning of hosts to certain namespaces. And so what we did was added several new NVMe administrative commands and operations for the creation and management of exported NVM subsystems and populating those NVMe or fabrics exported subsystems with namespaces that link to actual namespaces, and managing the exported ports and the access controls through the allowed host list, which you populate for each namespace based on the host NQN of the host that you want to be able to access it, assuming you want to restrict access. And then finally, we have NVMe management infrastructures, the high availability out-of-band management. And this allows multiple management controllers to manage an NVMe subsystem for high availability use cases. And there's been some good talks on this, so I'm not going to go into much more detail. And since I'm running out of time, I'm going to skip to the NVMe planned feature roadmap. Before we go into much detail, I'm going to kind of give an orientation on how to read this. If you look at each bubble that represents either a planned feature or a feature that we've ratified, look at the left vertical line for that box. That is the quarter in which we either ratified that feature or plan to ratify that feature. For example, if you look in the upper left in 2022 for NVMe or Fabric Automated Discovery, if you look at the left vertical line, you can see that we ratified that in the beginning of Q2 of 2022. And so the green and the gold, yellowish, oranges boxes there, those are the features, at least the marquee, the major items that we had on our roadmap that we've ratified. And if you look at on the far right in 2025, this is the major work that we've undertaken that we want to complete in 25. And this includes NVMe support for CXL, which you'll see a presentation on presently, quality of service enhancements, fabric resiliency enhancements, and post-quantum security enhancements, which is an increasingly important topic that we're spending a lot of time on. NVMe technology, it continues to grow, and adoption is increasing, and it's succeeded in unifying the client and the cloud and the AI and the enterprise infrastructure around a common architecture. NVMe has become the language of storage, and systems are being built using NVMe as the underlying storage technology with cell phones and tablets and laptops and desktops and storage arrays and data centers, even automotive applications. And we have a dedicated, vocal, passionate set of people in the NVMe technical community that maintain the existing specifications while developing new innovations, as I hope have impressed upon you with the new technical proposals that you see in the new specifications. NVMe began not that long ago as a very small, simple PCI-based SSD specification, and it's grown into nearly a dozen specifications supporting all major transports with the capacity of growing to support other transports and other fabrics. Supporting multiple command sets, again, with the capacity of being added to support multiple command sets when workloads and the environment requires. And standardizing many of aspects of storage. And I want to close by repeating, technical proposals are made public when they're ratified. Specification updates, they merely aggregate the technical proposals that are ratified since the last specification update. And thank you for your time.